Hello everyone, myself Mrs. Archana Mhatre, lecturer in Electronics and Telecommunication Department. In this video, we are going to continue with the third unit of Basic Electronics, that is bipolar junction transistor. Here first we will see the concept of DC load line. To understand the concept of DC load line, consider the common emitter configuration. Now this is the circuit diagram for common emitter configuration. So, the procedure to plot the DC load line by applying Kirchhoff voltage law to the collector circuit, we get VCC minus VCE minus ICRC is equal to 0. Let's consider as equation number 1. Rearranging this equation, we get IC is equal to minus 1 divided by RC into VCE plus VCC divided by RC. Compare this equation with general equation of a straight line, that is y is equal to mx plus c. The comparison shows the following result, that is y is equal to ic, m is equal to minus 1 divided by rc, x is equal to vce and c is equal to vcc divided by rc. Now substitute the VCE is equal to 0 in the equation number 1. So we will get IC is equal to VCC divided by RC, which represents the point A. Substitute the IC is equal to 0 in equation number 1. We will get VCE is equal to VCC, which represents the point B. Here you can see in this graph, this is a point A, which value is VCC divided by RC, and this is the point B, which value is VCC. Now next, Quiescent point or Q point, also called as operating point. The Q stands for quiescent, which means still, quiet or stable. Q point is the point on the load line which represents the DC current through the transistor IC and the voltage across it, that is VCE, when no AC signal is applied at the input. The DC load line is a set of infinite number of such operating points, and the user or designer can choose any point on the DC load line as an operating point. The goal is to set the Q point such that it does not go into saturation or cutoff when an AC signal is applied. Selection of Q point. Now here there are three figures, which first figure indicates Q point position to operate the transistor as an amplifier when it will be on this DC load line, center of the DC load line, then transistor will act as an amplifier. When it is Q point is in cutoff region, then the transistor will act as an open switch, and when the Q point is in saturation region, the transistor will act as a closed switch. The position of the operating point on the load line is dependent on the application of a transistor. We need to design a biasing circuit so as to locate the Q point on the DC load line as per the requirement of an application. If the transistor is being used for amplification purpose, then the Q point should be exactly at the center of load line. If the transistor is to be used as an open switch, then the Q point should be placed in the cutoff region as shown in figure B, and if the transistor is to be used as a closed switch, then the Q point should be in the saturation region as shown in figure C. Factor affecting the stability of Q point. Ideally, the Q point is expected to be stable, that is, should not shift up or down on the DC load line, but practically it is not possible. In fact, the Q point is quite unstable and keeps changing its position on the DC load line. The factors affecting the stability of Q point are: first, changes in temperature, and second, changes in the value of beta DC. variation of parameters from the one transistor to the another transistor. However, the Q point instability due to any reasons is not desirable because it will introduce distortion in the amplified signal. Now, Q point stabilization. The bias stabilization is a process of stabilizing the position of the Q point or bias point. We have seen that the bias point changes its position on the load line due to the factors such as change in temperature or device to device variations. If the Q point gets shifted towards saturation or cutoff region, then the amplified output waveform is distorted. In order to avoid such a distortion, it is necessary to stabilize the Q point at the center of the load line. So, we need to design a biasing circuit which will keep the position of Q point stable on the load line. First, Q points instability due to temperature. The junction temperature of a transistor is dependent on the amount of current flowing through the transistor. Due to the increase in temperature, the following parameters of a transistor will change, that is, first, voltage from base to emitter, beta DC value, and ICBO. Q points instability due to changes in beta DC. The current in beta DC for a given type of transistor normally has a very wide range. The value of beta DC may typically ranges from 50 to 150 or more depending on the value of IC. So, if we replace a faulty transistor by a new one having the same number, then its beta DC can be largely different than that of the old one. This will change the Q point. Q point instability due to variation in parameters from one device to another device. Two transistors of identical numbers, for example BC147, do not have exactly the same characteristic. Important parameters such as beta DC will differ in value from one transistor to the other. Hence, if we replace one transistor by the other of same number, the Q point is going to get shifted. Next, biasing stabilization technique. Bias stabilization means techniques used to stabilize the Q point. Some of them are as follows. First is fixed bias circuit, base bias with emitter feedback, base bias with collector feedback, voltage divider bias circuit, emitter bias circuit. Now, steps to obtain the DC operating point. For every biasing circuit, we have to obtain the DC operating point or Q point. The steps to determine the Q point are as follows. First, to draw the base circuit, calculate IB by applying KVL to the base circuit. Calculate IC is equal to beta IB. Draw the collector circuit, calculate VCE by applying KVL to the collector circuit. Thank you.